Yeah, well, nothing's usually
No, wait, two more minutes.
All right, y'all. Let me teach you. We're gonna keep going, and then I'm gonna record it for the people who aren't here. Again, it's because it's better for you later. After spring break, here's what's going on. You guys, we're not gonna finish the whole unit. We still have one more section, but that section takes forever. So we have 2 days. So that would be Monday and Tuesday that we're spending on the packet. And then I think we should test on this before the AP test, otherwise it's kind of weird. So we're gonna figure out a way to test. But what I'm saying is if we didn't do this section today, then we would have Monday, Tuesday, Wednesday, that we have to take notes, review on Thursday, and then take the test on Friday seems kind of quick. So I want at least Wednesday and Thursday to review or something like that.
I take a test on Thursday. And give you a printer test on Thursday.
I was thinking of doing something like that, right now my plan, well, I don't want to oversay, because they might change over spring break. They might change over spring break, I don't know. I don't know what's best for you guys, I gotta think about it. But the plan was maybe do 10-8 Monday, Tuesday, then review Wednesday, or just give you time to work on the homework or whatever. And then Thursday, do a partner test with the hard type questions, like the AP type questions. But it's open note and with your partners and whatever. And then Friday, do a solo test with a solo little quiz with the easy questions. That's what I was thinking of doing. That way, they both together add up to the 50 points that a normal test would have added up to. Yes? On what? No, of course you guys are going to vote for the easy thing. But I'm trying to think what's best for your learning, for you to learn it good before the AP test.
Oh.
Yes?
Wait, do you think we want to do the?
You guys will all pass the class. Nobody's going to fail the class. You guys all just want an A.
Yeah.
Without having to work real hard, without having to learn the material.
And that's okay.
That's not okay. How are you going to get an A? Also, what we can't take a vote on is how you want to review, because for that, I keep going back and forth. This is all going to be in the video. But I keep going back and forth on how you want to review for the AP test, because I don't know if you want we have 3 weeks to review. Here's a calendar. This is this week. This is spring break. This will be Unit 10 wrap up. So then you have 1, 2, 3 weeks, and then the test is this Monday, 13. Okay, so we have 3 weeks, 3 weeks to review for the AP test. I don't know if I just want to, I don't know what would be best for you. Do I just give you 2017 AP test, work through it? 2018, 2019, work through it? I don't know. Or do you want to do here's a semester 1 summary, and here's some AP questions that are like that. Semester 2 summary, and then all together. Okay, but then the semester 1 summary is we've done one of those. So I don't know if I should just get out that same packet and give it to you, or figure out something. I don't know. But if you guys like that idea, I'll think about how to summarize semester 1, how to summarize semester 2, and then just take AP tests on the last week. And then I don't know if I'm going to do it this year with the baby, but normally every year, the day before the AP test, which lately has been, they usually do the AP calculus test on a Monday. So on the Friday before, I usually stay real late. For whoever wants to be here and do math for forever. And if there's money, if the school gives me money, then I'll get 1,000 pizzas, and whoever wants to come can like come and eat pizzas and drink sodas and study and take AP tests and like practice tests and stuff, and come and go as you please. If you want to come in at 6 and leave at 8:30, that's fine. If you want to come stay from 3:30 to 7:30, that's good. That's normally what I do. If I can do it this year, I will, but I gotta check that that's okay with the baby and my wife. But that's something to think about. All right, anyway, after all that, let me teach you. Well, everybody's got to do the semester one wrap up. Yeah, maybe we should keep it. All right, we'll vote later, but I'm gonna forget, so remind me. All right, anyway, think about how you want to start reviewing for the AP test. We'll take a vote later. If you think of better ideas, like your other AP teachers have better ways of reviewing than just semester 1, semester 2, and then whole AP test, like let me know. Because I can't think of anything other than giving you whole AP test or wrapping up semester 1, semester 2. Okay, yeah, let's just stop there, and then let's start learning.
You got it.
Okay, so 10.7, this has a bunch of stuff on here that I don't think I want to read you because all it does is kind of confuse what you already know. So all this is saying is here we learned about how, basically 10.6, we learned about how you can approximate functions with polynomials. They're now calling those polynomials a power series. Basically, is what you have to take away from here. This you already know, like I said, this is just like 10.6, but now they're calling it power series instead of like Taylor polynomials or whatever. You might hear those terms like interchangeably. Power series, Taylor polynomial, Maclaurin polynomial, all of them mean the same thing. And then here is what I had this little graph up for. So watch this. Here's like the motivation for this section is that you may or may not remember geometric theory. They look like this. And these converge when r is less than 1, remember that? What you may not remember is that these converge and they give us a formula for what they converge to. Like if you were to add these forever and r is less than 1, then you get this as the sum, which a lot of you guys saw on your homework. That's an r. Okay. So based off of this idea, if I just replace this r with an x, then I should get that this function, 1 over 1 minus x, should be the same as this series, x to the 1 times x to the n. You seeing kind of what I'm saying? If this is equal to this, then the function 1 over 1 minus x should equal x to the n, the sum from of x to the n. Okay, but then look what happened, and you tell me why it looks so funky. Look at, first of all, look how accurate that is over here in that little section. But then eventually it peels off, and it's not because I'm only going 30 terms, because watch this. Here's 31, here's 32, here's 33, here's 50. No matter how far I go, it's always going to peel off at some point. Do you have any idea why that's going on?
For the first equation, like as it approaches,
You're talking about the asymptote? Yeah, okay, but the asymptote, well, okay, yeah, that's true, but then why is that explaining this stuff over here? Yeah, you guys may not have a good idea, but remember how my disclaimer for this was as long as R is less than 1, then this will converge to this. So what I'm saying is if X is bigger than 1 or smaller than -1, then this is going to diverge. So what I'm saying is sometimes your power functions, your Taylor polynomials that we did in 10.6, they don't converge to your series won't converge, meaning you'll get something that accurately represents your function up to a point, and then where you plug in x's that are too big and it makes the series diverge, then it'll peel off and it won't be a good approximation of your function anymore. So what I'm saying is here, over here, that should be the point -1, or real close to it. Yeah, there it is, -9.49. That's where it peels off because any bigger x's are going to make this too big to ever converge. And therefore, it's not a good approximation of my sum anymore, of my function. But basically what I'm saying is, oh, that's the wrong computer. Basically what I'm saying is that your functions, let me delete all that. Your functions, your power series, your Taylor polynomials, are going to have an interval where they converge. That interval may be infinite, like for e to the x. It may be that it never converges unless it's at the center, or it may be that there's some radius where it converges, like the one I just showed you. This shouldn't make sense to you yet, but you'll see what I'm talking about as we do some examples. So what time do you guys leave? 25, okay. Do I want to review that yet? I don't think so. I think I'm going to save that for last and save this example 1 for last. So yeah, join me in the next page, page 22, as we find the integral and radius of convergence of these 3 series. So again, you're asking what x's can I plug into this so that this series converges? So you're thinking of this x as a static thing that you're plugging in and then taking the series. So I plug in 1, find out what that value is, and then find out if the series converges or diverges. If that didn't make sense, it'll make sense as we do an example. But again, sorry for skipping around so much, but I did this morning and I found out that the easiest order would be to do C first, I believe. Yeah, C, B, A will go backwards. It'll make the most sense. It's like from most basic to least basic. So let's do part C first. Okay, find the intervals of convergence. Okay, as in what x's can I plug into here so that this series will converge? Like for example, if I plug in 5 in for x, that would be 5 minus 3 is 2, so this series would turn into n factorial times 2 to the n, and we determine whether that converges or diverges. But we kind of do it all at once. Like not doing it x by x, like plugging in x value, x value, x value, and then checking. But we do it all at once in the following way. Remember 10.5, how we did the ratio test? That's what we're going to do. And if you don't remember 10.5, then here's a reminder. Ratio test says, take the limit as n goes to infinity of the absolute value of this series, but with an n plus 1 plugged in. And then divided by that same series with an n plugged in. Okay, then let me check how much you remember. This will converge if this limit is, do you guys remember how much? Yeah, all right. Well, if you went back, what is it? Yeah, good job. This will converge if this limit is less than 1. So that's what we'll be checking in a second. If this is less than 1. Okay, but first let me simplify this as much as I can. Limit as n goes to infinity of Here's me simplifying. Do you guys remember how these factorials would simplify? N plus 1 factorial over n factorial.
You just.
No, but close. N plus 1 factorial, let me make it a little board. Remember, n plus 1 factorial means n plus 1 times n minus 1, etc., all the way down to 1. So this is how we've written it before. N times 1 times the previous number times the previous number times the one after that, all the way down till I get to times 2 times 1. N factorial is the same thing, just with n. So n times n minus 1 times n minus 2, all the way down till I get to times 2 times 1. So yeah, all that's left is these will all cancel, and n plus 1 will be all that's left. Good job. So then this would be the limit of n plus 1 on top. And then, do you guys remember how these would cancel? Yeah, just subtract the exponents basically, and you get x minus 3. Sorry, n plus 1 minus n is just with the 1. So I just get x minus 3 to the first. N plus 1 times x minus 3 to the first, but I'm not going to write to the first. And then that's the limit that I'm taking. And then this at first can look really intimidating because it's like, oh, n and x, oh my god, holy cow. But it is not that crazy. Remember, this x is staying static. Like you're pretending like you've already plugged in a number into here. The only thing that's changing is the n. So, okay, pretend you plugged in a 2 into here or whatever. You plugged in a number into here. N is changing. It's getting huge. What's going to happen to this limit? Yeah, this is infinity times a number. So this would go to infinity. Okay, and now you tell me, is infinity less than 1? No, of course not. So this will never converge. No matter what x I plug in, I'm always going to get an infinite limit. So this will never converge unless, you guys see the only way I can make this be smaller than 1? There's one number that I can plug in for f. Yeah, if I plug in 3 for f, the 3 minus 3 is 0, then I get 0 times whatever. So that's always going to be 0. So therefore, this only converges when x equals 3. So up at the top where it says find the radius and interval of convergence, the interval doesn't exist because it's only 1 point. Eventually you'll get like it converges if it's between 3 and 5 or something like that. In this case, we only got x equals 3, and therefore the radius is 0. You'll see what this means when we get a normal interval. Okay. Is this making sense? Slowly? Okay, that's the most basic example. The next one is the next most basic. You're going to have to remember. Yeah, r equals 0. The radius of convergence is 0. Because from my center, I can't move. Like from my center of 3, I can't move to the right or left any. Like I can't plug in 3.1, I can't plug in 4, I can't plug in whatever. So I'm like, you'll see more when we do an example. All right, this one, same thing. Let's do it in the same way. Here's me doing the ratio test. I was like right pretty small and all the way over here just to like give myself a lot of room. I recommend you do the same thing.
You have to use the ratio test.
Yeah, for these you always use the ratio test, always. Good question. Okay, limited n goes to infinity of absolute value of this with an n plus 1 plugged in divided by this with an n plugged in. But again, I'm worried a little bit about the space that I have. So let me do a couple things at once. I'm gonna plug in my n plus 1 right now, but then I'm not gonna divide it by this fraction. Instead, I'm gonna just skip that step and do the keep change flip already. So I'm not gonna be doing fraction divided by fraction and then keep change flip. I'll do it all at once. So here is me plugging in n plus 1. 2 times n plus 1 again, over 2 times n plus 1 factorial. Okay, and then if I had all the space in the world, I would divide this by exactly the thing I see. But since I don't have that much space, I'm just going to be multiplying by the reciprocal right now. That would be times 2n plus 1 factorial over -1 and x to the 2n plus 1. Okay, are you lost or do you see what I did? All right, okay. Then I simplified as much as I can. It would be nice to find out what this is. In fact, again, since I don't have all the room in the world, let's just simplify these real quick off to the side. 2n plus 1. Hopefully you see that if I distribute that 2, that would just end up being 2n plus 3. Agreed? Like if I distribute the 2n plus 2, and then plus another one, 2n plus 3. Okay. So, yeah, okay, I'll write that. I'll write a middle step, but let's simplify everything we can right now. So that would be, look at how -1 to the n plus 1 divided by -1 to the n. That's just going to be -1.
Hey, how would why is it 2n to the n plus 1? Not just 2n plus 2 or something?
Yeah, that's the temptation, is just do one more. But if you plug in n plus 1 for the n,
I see, yeah.
for that n and for that n, you're replacing that n with the whole n plus 1. I forgot what I was saying. Oh, about the -1. See how the -1s are going to cancel? N plus 1 and n. I'll just get left with a -1 on top. Okay, so let's simplify this as much as we can in as little room as possible. That would be a -1 up here to no power, just to the first power. X to the 2n plus 3, we agreed, times 2n plus 1 factorial divided by 2n plus 3 factorial times x to the 2n plus 1. Okay, all right, now we're getting somewhere. All right. Then, let me do one thing. Let me do a couple things. Hopefully you agree that the absolute value of -1 is just 1. So this -1 isn't really doing anything. Like, whatever I get from the stuff without the -1, multiplying it after by -1 and then taking the absolute value is just going to give me the exact same thing. Because the absolute value of -1 is just 1. So let me get rid of this -1 that's just in the way. Not going to write it. Then also x to the 2n plus 3 divided by x to the 2n plus 1. You tell me what that's going to be. X to the 2, I thought.
Oh, yeah.
Yeah, because look, this minus this would just be the difference
Yeah.
of 2. Okay. So x squared, no -1 anymore, and then 2n plus 1 factorial over 2n plus 3 factorial. If you get this right, I would be very impressed, but I bet there's something you're missing. You guys know how that would simplify? If you combine your two answers that you just whispered, that would be right. Again, this one has 2 more terms than the top one. So if I go back to this little board and I do the same thing, 2n plus 1 times 2n plus 1 minus 1 would just be this, and 2n minus 1, all the way down, all the way down to times 2 times 1. 2n plus 3 would look like 2n plus 3 times the previous term, so 1 less than that. Times 2 times 1. So you can see this has 2 more factors. All of these cancel, and you're just left with that on the bottom. Okay. 2n plus 3 times 2n plus 2, just the last two factors. Okay, there you go. And then now this looks pretty nice to take. Remember the x, you already plugged in. You're pretending you plugged in a 3 or a 9 or whatever. You plugged in a number already to the x. The n is what's changing. So what's going to happen if I plug in huge n's and this is the same clip? Yeah, this will go to 0. This would be like, whatever you plugged in, let's say you plugged in 3. This would be 9 over 3 trillion, 9 over 4 quadrillion, because the n's are getting annoying. So 9 over 3 quadrillion is very, very small, so this limit would be 0. Okay, so notice we said plug in anything for x, that limit is still going to be 0. Therefore, this is always going to converge. So that converges for any x that I plug in. So it converges for all x. And therefore, that rate, they call that the radius of convergence being infinity. As in, if you start at your center, in this case, the center was 3. Here, the center would be 0. If you start at your center, you can move to the left or right any amount and plug in that number. If you can move to the, you can plug in 1,000 if you want, and it would still converge. Anyway, there's your answer. Hopefully that's making some sense. And then 10 minutes for the last one. I don't know if we got, well, okay, we'll try it. That one is, this one is like the most common, the most important. All right, this one, same thing. Let's, I'll move a little bit more quickly since you've seen all the tricks with the n plus 1 and everything. So I'm taking this limit as n goes to infinity of, again, I'm going to skip the division of two fractions and just move straight to the keep chain flip. That would be -1 to the n plus 1 plus 1. In this case, there's no extra little trick. There's no factor in front of the n. So this would just be n plus 2, I hope you agree, times x minus 5 to the n plus 1 over n plus 1 to the 2n plus 1. Yes, everyone good with this? Okay, and then divided by the exact thing that you see. But again, I'm not going to do fraction divided by fraction because I have limited amount of room. I'm just going to keep change flip right away. So this times n to the 2n over -1 plus 1. X minus 5 to the n. Okay, then make sure this makes sense in your brain. Yeah. I know, yeah, it's kind of crazy. I mean, once you see it, it's like, oh, okay, that makes sense once you get taught it. But yeah, how do you come up with it on your own? That's kind of crazy. Yeah. Okay. All right. Then let us simplify as much as we can. Watch this. Again, -1 has 1 more power than the -1 on the bottom, so I'm going to be left with a -1 on top. But even then, I'm going to be taking the absolute value afterward. So as you saw down here, that -1 isn't going to be doing anything after the absolute value, so I'm not even going to write it. I'm just going to get rid of the -1. If you want to write that middle step with the -1 in there, okay, do it. But I'm ignoring the -1. They're not doing anything to the absolute value. Okay, then I have x minus 5 to the n plus 1, x minus 5 to the n. This has 1 more power than this one, so I'm going to be left with, and then goes to infinity, x minus 5 to the first up top. Okay. Then what else? Okay, I've dealt with this, dealt with this, dealt with this, dealt with this. I have an n up there as well. That can't cancel with this n minus 1 down here. Sorry, yeah, plus 1 down there. And then I have, okay, dealt with the n's. They can't cancel. And then 2 to the n plus 1, there's one more power on the bottom. So that would be a 2 down here. Okay, and then again, you look at that and it looks a little bit crazy because it's got x's and n's, but again, you're thinking of the x as static, like you've already plugged in a number, you plugged in a 7 or whatever. And you look at just the n part. Okay, the limit as n goes to infinity of n over n plus 1, do you guys remember what that would be? Like, because they have the same, this is n to the first, n to the first. Yeah, so that would just be 1 without the coefficient. With the coefficient, it's just equal to the ratio of the coefficient. So it'd be, this limit right here would equal the absolute value of x minus 5 over 2. Okay, and then here's how these usually go. Sometimes you get the infinite radius, sometimes you get the 0 radius, like in B and C. Here, this is the more normal type of question that you're going to get, where you'll get some x minus 5 over 2 or something like that, and you're wondering, when is this going to be less than 1 so that it converges? Agreed? When is this limit less than 1? Okay, so then you set this less than 1, and you solve for x, and that's it. But solving, I don't know how much you remember about solving absolute values. We have 5 minutes, so we got to kind of move fast. But remember, absolute values could mean either this is less than -1 or it's bigger than -1. Again, absolute value less than 1 would mean like numbers like 0.5 or -0.5. So all the numbers between 1 and -1. Okay. So this is the way you solve these is the same. X minus 5 over 2 is less than 1, but bigger than -1. So between -1 and 1, like that. Then you solve for the f, and then you're almost done. Yeah, I don't know if we'll finish this in 5 minutes, but we'll try. Okay, you multiply all the sides by 2. -2 less than x minus 5 less than 2. Then you add the 5 and you get 3 is less than x is less than 7. This is basically your answer. Except for one thing. That one thing is that if so the ratio test says for sure this will converge absolutely if it's less than 1. If the limit is less than 1. But if the limit was exactly equal to 1, then it could converge or it could diverge. So then once you get your interval like this, you have to check your endpoints, which you will see. You guys don't have to flip back, but let me convince you that I'm not making this up. Every time you find the interval, you must check to see if the endpoints are included. So what I mean is now that you have your interval, now do a quick check of the endpoints. Oh, okay, let's see if we can get this done. To see if the endpoints converge, and if they do, great. If they don't, then you don't include them. So watch this. Here is me checking my endpoints, as in plugging in 7 for x and 3 for x, and checking which one of those converging, or if they both do, or if neither one. Okay, there's me plugging in x equals 7. Okay, then 7 minus 5 will be 2. This is going to turn into the sum from wherever to wherever. Just trying to rush. N plus 1 times 2 to the n over n to the 2 to the n, or times 2 to the n. And this is the type of thing that is always going to happen. These, basically your constants, or some things will cancel. You'll end up that this is a constant that canceled on the bottom or something like that. So see how it's 2 to the n over 2 to the n, those guys will cancel. And then you get this sum. 22, okay. You get this sum left over. You guys remember if that sum will converge or diverge, or is this a question? If you're saying diverges because why? Yeah, because it's harmonic, except be really careful. No, the normal, if we got 1 over n, it would diverge because it's harmonic. -1, the alternating series, remember how those have a better chance of converging? I don't know how much you remember about the 10.4 from Monday, but this would actually converge. The -1 to the n plus 1 over n, that one actually converges because of the alternating series test, which just says, like, does this have a limit of 0? Yeah, it does, so it converges. If you don't believe me, go back and check your 10.4 note, but that one actually converges. Therefore, I include the 7 that I plugged in. So less than or equal to. And then in 2 minutes, okay, if I were to plug in a 3 into here, I would get I don't have that much room, but let me just show you. Plug in a 3 into there, let me not fill in the little bound. Plugging in a 3 into here, I would get 3 minus 5 is -2 to the n. Okay, -2 to the n is the same thing as -1 times 2 to the n over whatever. -1, or like number times number to the n, just means number to the n times number to the n over this. Then here you can see -1 to the n times -1 to the n. These are going to make -1 to the 2n plus 1 if you add the power. These will cancel, and you'll just get left with that. Oh, I wish I didn't have to do this in 1 minute. I'm sorry. I know it's confusing. But these cancel. I get -1 to the 2n plus 1 over n. 2n plus 1 is just the odd numbers. Like plug in 1, plug in 2, plug in 3, plug in 4. You'll see that you're only getting odd numbers out of here. And so this is really just the sum of -1 over n. So not an alternating series, just a negative series, which diverges. So I don't include the 3. So I'm done. I don't include the 3. I don't put a little line. And, sorry, one more thing. It said find the radius. The radius would be how far can you go from your center. My center was 5, and I can go 2 to the right and 2 to the left. So my radius is 2. I'm sorry, you guys. I'm sorry.